So we will discuss the finder collimator device. Finder collimator device. All right. Have you seen the rifle? On the top of the rifle, there is a small point, small solid things through which you can see it. Okay.
Yes, sir.
So that is the finder collimator device in order to sight that in order to sight towards the object. Okay, this is provided on the top of the telescope in the case of initial setting. So it can also be considered as rifle sight as you are seeing this
Yes, sir.
here. This is finder collimator device through which you can see. All right.
Yes, sir.
So write down. It's a pair of external sights. It's a pair of external sights fitted fitted on the top of the telescope. Fitted on the top of the telescope. Written.
Yes, sir.
Fitted on the top of the telescope. For rough shifting of the telescope. For rough sighting of the telescope. For rough sighting of the telescope towards the object. For rough sighting of the telescope towards the object. For rough sighting of the telescope towards the object. Written.
Yes, sir.
So write down. It is also used for the easiness of initial setting. It is also used for the easiness of easiness of initial setting. Written.
Yes, sir.
Next, write down also known as rifle sights. Sorry. Written.
Yes, sir.
Now we have tripod. We have tripod. What is tripod? This is type of leg. Okay. So the theodolite is mounted on a strong tripod. Okay. When you are using the field. So the legs of the tripod are solid. Solid legs we have. All right. And on the top of the telescope, on the top of the tripod, the leveling head of the theodolite is screwed with the help of male screw. With the help of male screw. as well as bottom end is pointed in order to insert in the ground. Bottom end is pointed. All right. So they can be pushed. They can be easily pushed into the ground. All right. So we can say that in order to prevent the wear and tear of the bottom end, sometimes at the lower end of the legs, pointed steel shoes are provided. Pointed steel shoes are provided, and the tripod head has male screw. Has male screws on which the theodolite can be, yeah, leveling head assembly of theodolite, or which one? Trivet. Trivet. Okay. Which one? Trivet. Trivet is a part of the leveling head assembly, lowermost part, which is screwed to the tripod. Write down. Written.
Wait, sir.
So now write down topics, important definitions. Very much important for A and J exam. Important definitions. All right. So first is what? Let's see here. So what is vertical axis or azimuth axis? So vertical axis or azimuth axis both are same. So it is the axis about which the instrument can be rotated in horizontal plane, like this way. Can be rotated in horizontal plane. So or we can say that this is the axis about which the lower and upper plate rotates. Lower and upper plate rotates. Another is horizontal axis, that is the Trunian axis, or the axis about which the telescope and the vertical circle, because both are attached to each other, rotates in vertical plane. That's called Trunian or horizontal axis. Another is line of sight or line of collimation. So obviously we have the crosshairs, horizontal and vertical. This is the intersection of the crosshairs. All right. And there would be the optical center of the object glass and its continuation. There would be the optical center of the object glass and its continuation. That means if this is the optical center of the object glass, so when you are seeing when you are seeing through this intersection of the crosshairs, and that ray pass through the optical center of the optical center of the object glass, or your objective lens, and it proceeds further on. So that's ray of light is known as line of sight or line of collimation. That's ray of light is known as line of sight or line of collimations. All right.
Yes, sir.
So write down. First write down vertical axis or azimuth axis. The vertical axis or azimuth axis written.
Yes, sir.
it it is the axis about which it is the axis about which It is the axis about which the instrument can be rotated in a horizontal plane. The instrument can be rotated in a horizontal plane. That is that is the axis about which the lower that is the axis about which the lower axis about which the lower and upper plate rotates. Lower and upper plate rotates. Written. Written.
Yes, sir.
Next, write down horizontal axis. Write down. It's also known as Trunian axis. Written on the board. It's also known as Trunian axis. Trunion. Trunian axis. Written.
Yes, sir.
So it's the axis about which the telescope and the vertical circle. It's the axis about which the telescope and the vertical circle. It's the axis about which the telescope and the vertical circle rotate in vertical plane. Rotates in vertical plane. Written.
Yes, sir.
Write down the note. Also known as transverse axis. Also known as transverse axis. Also known as transverse axis. All right.
Yes, sir.
Next, write down line of sight or line of collimation. Line of sight or line of collimation. Line of sight or line of collimation. Written.
Yes, sir.
Write down is the line passing through the intersection of the horizontal. It's the line passing through the intersection of the horizontal. It's the line passing through the intersection of the horizontal. It's the line passing through the intersection of the horizontal and vertical crosshairs and the vertical crosshairs and the vertical crosshairs. Written.
Yes, sir.
And vertical crosshairs and the optical center of the object glass and the optical center of the object glass and its continuation and the optical center of the object glass and its continuation. Okay.
Yes, sir.
Now write down axis of label tube. Axis of label tube. All right. This is the label tube. So suppose this is the label tube. When you draw a tangent line to the label tube, to the we can say that to the longitudinal curve of the level tube, or we can say that, okay.
Sir, not audible.
Audible? Now audible?
Yes, sir.
Now, okay. So when this level tube is at its center, then only you are drawing a tangent to this level tube. This is the longitudinal curve of the level tube. All right. Then this represents axis of level tube. All right. And remember one thing. When this level tube is at its center and there would be no any error, then this axis of level tube would remain horizontal. Would remain horizontal. So what is this axis of level tube? This is the line tangent line drawn, or we can say that a straight line drawn or tangential to the longitudinal curve of the level tube at its center. And when the bubble is at its center, this axis of level tube will be horizontal. So write down axis of level tube, or the bubble tube, axis of level tube or bubble tube, axis of level tube or bubble tube, axis of level tube or bubble tube is a straight line. Audible?
Yes, sir.
Is a straight line is a straight line tangential to the longitudinal curve is a straight line longitudinal to the straight line tangential to the longitudinal curve, okay,
Yes, sir.
is a straight line tangential to the longitudinal curve of the level tube at its center, of the level tube at its center, of the level tube at its center. Written.
Yes, sir.
So write down a note, draw this figure and write down a note. The axis of the level tube is horizontal. The axis of a level tube is horizontal.
This torque will tend to align the dipole with the field E. When P is aligned with E, the torque is zero. What happens if the field is not uniform? In that case, the net force will evidently be non-zero. In addition, there will, in general, be a torque on the system as before. The general case is involved, so let us consider the simpler situations when P is parallel to E or antiparallel to E. In either case, the net torque is zero, but there is a net force on the dipole if E is not uniform. Figure 1.20 is self-explanatory. It is easily seen that when P is parallel to E, the dipole has a net force in the direction of increasing field. When P is antiparallel to E, the net force on the dipole is in the direction of decreasing field. In general, the force depends on the orientation of
Draw on the figure. Draw the figure.
Sir.
So write on a note. The axis of the level tube is horizontal. The axis of the level tube is horizontal when the bubble is central. When the bubble is central. Written.
Sir, can you please repeat?
The axis of the level tube is horizontal. The axis of the level tube is horizontal when the bubble is at its central. Written.
Yes, sir.
Now write down centering. So what is centering? Centering is nothing. When you have to set the theodolite exactly over the station mark, then we do the centering. And a plumb bob that we see and we studied earlier, that plumb bob is suspended from a small hook, circular hook. Already told you, from the lower plate. From the tri branch, lower portion of the tri branch. तो स्मॉल हुक को सस्पेंड करते हैं जो अंडर साइड होता है हमारा इनर स्पिंडल में. So that is used for precise centering. That is used for precise centering. Okay. Whenever we have windy weathers, then we use optical plummet. We use optical plummet. So write down centering. Written.
Yes, sir.
So write down centering is done to place the vertical axis or theodolite. Centering is done to place the vertical axis or theodolite exactly over the station. Centering is done to place the vertical axis or theodolite exactly over the station. Written.
Yes, sir.
And for precise centering, we use plumb bob. Okay. Write on a note. Written.
Yes, sir.
Now what? Let's know what I'm teaching you. Approximate centering. All right. This is very much important. So write down, see, approximate centering is done by, you must have done in your school, college lab, you move the tripod legs either radially or sideways. Remember, when you are moving it radially, then plumb bob will shift in the direction of the movement of the legs. But while shifting plumb bob, while shifting, the leveling of the instrument will not be affected. Leveling of the instrument affect नहीं होगा. But when you are shifting it sideways, तो वहां भी plumb bob shift होगा, centering हो सकता है, but instrument का leveling क्या होता है हमारा affect हो जाता है. The leveling of the instrument will be affected. So write down a note. Approximate centering is done with the help of the tripod legs. Approximate centering is done with the help of the tripod legs, which are moved radially or circumferentially. Which are moved radially or circumferentially. Which are moved radially or circumferentially. Written.
Yes, sir.
So I write down another note. When the legs are moved radially, when the legs are moved radially, when the legs are moved radially, written. hmm?
Yes, sir.
The plumb bob shifts in the direction of the plumb bob shifts in the direction of the the plumb bob shifts in the direction of the movement of the leg, shifts in the direction of the movement of the leg, shifts in the direction of the movement of the leg without affecting the without affecting the leveling of the instrument, without affecting the leveling of the instrument. Written.
Yes, sir.
Next, write down when the legs are moved sideways or circumferentially. When the legs are moved sideways or circumferentially, when the legs are moved sideways or circumferentially, or circumferentially, then plumb bob does not shift much. Not write down circumferentially. Write down only move sideways. Move sideways only. Move sideways. Okay.
Sir.
Then the plumb bob does not shift. Then the plumb bob does not shift much. Then the plumb bob does not shift much. But the leveling is affected. But the leveling is affected. Written. Written.
Yes, sir.
Write down approximate leveling is checked with reference to a small circular bubble. Approximate leveling is checked with reference to a small circular bubble. Approximate leveling is checked with reference to a small circular bubble provided on the tri branch. Provided on the tri branch. Written.
Yes, sir.
Next, write down exact centering is done by the means of shifting head or centering device. Written. The
Yes, sir.
exact centering is done by the means with the help of shifting head or centering device. Write down next note. When there is windy conditioning the field, when there is windy conditioning the field, when there is windy conditioning the field, so obviously suppose there is a wind condition, so plumb bob will oscillate to and fro, obviously due to the wind effect. So in that circumstances we use another instruments that known as optical plummet. That's known as optical plummet. All right, what you have written? What you have written, gentlemen?
Which one, sir?
What the last things you have written? When there is, I told you na.
Yes, sir.
What you have written last?
The last one.
Huh. Tell me
Yes, sir.
what you have written last.
Which one, sir? What last one? Last class or
Abhi right now what I have told you.
uh, that uh the last part?
Write down when there is windy weather. When there is windy weather, then when there is windy weather, then we use optical plummet. Optical plummet. All right.
Yes, sir.
We use optical plummet for exact centering. Okay. Write down. Written. Written.
Wait, sir. Yes, sir, done.
Next, write down transiting and swinging of telescope. Transiting and swinging of telescope. Okay, this is very much important. Let's see here. Now let's see here what is transiting of the telescope. Basically, it's the process of turning the telescope in vertical plane. अगर आप वर्टिकल प्लेन में टेलीस्कोप को टर्न करते हैं थ्रो 180 डिग्री अबाउट ट्रिनियन एक्सिस, दिस इज व्हाट ट्रिनियन एक्सिस. So this is what transiting. Okay, so line of sight gets reversed in the transiting. That means objective comes towards eyepiece come towards objective. So that transiting is also known as plunging or reversing. Then what is the swinging of telescope? Swinging of telescope is process of turning the telescope in horizontal plane, like this way, like this way. That is the process of turning the telescope in horizontal plane. All right. So when the telescope is rotated in clockwise direction, it's known as right swing. It's known as right swing, like this way. Okay, this is the what? Horizontal plane. You are rotating about this what where? Horizontal plane. So when you are rotating in clockwise direction, that's known as right swing. When you are rotating in anti-clockwise direction, that's known as left swing. And very much important, if you are taking the average of right swing, if you are taking the average of right swing and left swing observations, then the effects or errors that we will study on later on, that's the error due to effect of friction or backlash, can be eliminated. So very much important, these two definitions. So write down transiting. It is the process of it is the process of it is the process of turning the telescoping vertical plane. It is the process of turning the telescoping vertical plane through 180 degree about the Trunian axis. Through 180 degree about the Trunian axis. Through 180 degree about the Trunian axis. Written.
Yes, sir.
So write down a note. Since the line of sight is reversed in this operation, since the line of sight is reversed in this operation, written.
Yes, sir.
This it's also known as plunging or reversing. It's also known as plunging or reversing.
Yes, sir.
Written.
Yes, sir.
Write down next, swinging of telescope. It is the process of turning the telescope in horizontal plane. It is the process of turning the telescope in horizontal plane. It is the process of turning the telescope in horizontal plane. It is the process of turning the telescope in horizontal plane. Written.
Yes, sir.
So write down note, if the note 1, if the telescope is rotating in clockwise direction, if the telescope is rotated in clockwise direction, rotated in clockwise direction, it's known as right swing. It's known as right swing. Written.
Yes, sir.
If the telescope is rotated in anti-clockwise direction, if the telescope is rotated in anti-clockwise direction, it's known as left swing. Written.
Yes, sir.
So write down note, another note, very much important. By taking the mean of, by taking the mean of by taking the mean of by taking the mean of right swing and left swing observations comma, the effect of friction, the effect of friction, the effect of friction or backlash, LASH, backlash in the moving part, backlash in the moving part, backlash in the moving part is eliminated. So what is the backlash? That is the gap between two moving parts. If somewhere there comes between the gap or one or gap between the two moving parts, that means the movement is not being done accurately, then we can do we can eliminate that error with the help of taking the reading, once one right swing, another left swing, and then what we'll do, we'll take the mean of the both observations, and that would be reported as the answer. So by taking the backlash in the moving part of the moving part is eliminated. Moving part is eliminated. Written. So this backlash is what? Is an error that is caused by friction in the moving parts. All right. Am I audible?
Yes, sir.
You are sleeping.
No, no, no. I'm listening.
Backlash in the backlash or moving part is eliminated. Written.
Yes, sir.
Now let's see here what is face left observations and face right observations. What are its benefits? Suppose it's a vertical circle. Your face of the vertical circle is left of the observation. Oh, sorry, observer, left of the observer. So in that circumstances, whatever the observation of the angle you are taking, either vertical or horizontal, that observations are face left observations. Similarly, when the face of the vertical circle is to the right of the observer, then that's known as face right observations. Both are applied in the case of both horizontal as well as vertical angles. And one more thing, if you want to eliminate the error due to collimation error, then if you are taking the average of the face left and face right and reporting it to be the answer, then you can eliminate the collimation error. All right, thank you. So write down face left observations. Written face left observations.
Yes, sir.
So write down if the face of the vertical circle is to the left of the observer, if the if the face of the vertical circle is to the left of the observer, is to the left of the observer, written,
Yes, sir.
then the observation of the angle bracket horizontal or vertical, then the observation of the angle bracket में horizontal or vertical, written.
Yes, sir.
So write down what you have written last.
To the observation.
To the observer of the angle, sorry, to the observer, write down if the face of the vertical circle is to the left of the observer, comma, the observation of the angle in bracket write down horizontal or vertical. The observation of the angle in bracket write down horizontal or vertical. Written.
Yes, sir.
Bracket close is known as face left observation. Is known as face left observation. Written.
Yes, sir.
Next, face right observation.
Surface observation.
Face right.
Face right.
If the face of the vertical circle is to the right of the observer, if the face of the vertical circle is to the right of the observer, face of the vertical circle is to the face of the vertical circle is to the right of the observer, written
Yes, sir.
to the face of the right face of the observer, then it's known as right face right observation. Then it's known as face right observation.
Done, sir.
Write on a note. Write down a note. By taking the average of the face right and face left readings, by taking the average of the face right and face left readings, by 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 taking the average of the face left and face right readings, written
Yes, sir.
readings, the collimation error is eliminated. The collimation error is eliminated. Written, collimation error is eliminated.
Yes, sir.
Next, write down telescope normal and telescope inverted. Written.
Sir,
Now
can you
let's
repeat?
now let's see what is telescope normal and telescope inverted. So this is very much important. Obviously, we can say that any telescope is said to be normal or direct when the vertical circle is to the left side of the observer and the bubble is up. So in these circumstances, we said that normal telescope or direct telescope. Okay. Similarly, inverted telescope, that vertical circle is to the right of the observer and bubble is down. Bubble is down. Okay. So this is normal and inverted of normal or inverted telescope. Thank you. So write down normal telescope normal. Written.
Yes, sir.
So write down telescope is said to be normal or direct A telescope is said to be normal or direct. Normal or direct when the vertical circle when the vertical circle is to the when the vertical circle is to the left side of the observer. When the vertical circle is to the left side of the observer. Written? Written?
Yes, sir.
Next, radon telescope inverted. When vertical circle is to the right side of the observer and the bubble is down. Written?
Yes, sir.
Wait a minute. So write down a set. What is the meaning of this a set? A set. So there will be two readings. Okay. We will when you are taking the observations, then we have to take two readings. One with the face left, another is or we can say that one with the telescope normal or face left, or another with telescope inverted or face right. So write down a set of horizontal observations of any angle. A set of horizontal observations of any angle horizontal observations of any angle written
Yes, sir.
consist of two horizontal measures. Consist of two horizontal measures. Written?
Yes, sir.
One with face left, another is face right. One with face left, another is face right. Written.
Sir.
So now write down recording. Okay. This is the axis of telescope. All right. So this is what? This is the Z collimation axis. This is what? Validate axis. Or this is what? Horizontal axis. This is what? Horizontal axis. Horizontal axis. And this is what? L. This is the axis of this level tube. Okay. Or axis of alided level or level axis. So these are the axis of total light you have to study. Remember this. Draw this. Written.
Sir.
Now, what is changing phase operations? Changing phase. So basically, this is the operation of bringing the face of the telescope from left to right or right to left. So how you change the phase? You change the phase by plunging the telescope. First, you have to plunge the telescope and then you have to swing it by 180-degree. So this is the changing phase. We have so many advantage of changing phase because so much error can be eliminated with the help of changing phase observations. First, error, as we have studied, that if you are taking the average of the readings of the face left and face right, you can eliminate the error due to line of collimations, or when line of collimation should be perpendicular to the horizontal axis. All right. So if the line of collimation is not being perpendicular to the horizontal axis, then you can take the both readings, face left and face right. As well as if the horizontal axis is not being perpendicular to the vertical axis, then this error can also be eliminated with the help of taking the mean average of the face left and face right observations or changing phase operations. As well as if the line of collimation is not being parallel to the altitude level, then also we can rectify the or we can eliminate the errors by taking the face left and face right observations or changing phase operations. So write down, changing phase is the operation of bringing the it is the operation of bringing the face of the telescope. It is the operation of bringing the face of the telescope from from left to right, from left to right and vice versa, from left to right and vice versa. Written. Written.
Wait, sir. Wait.
Faced from left to right and vice versa.
Yes, sir.
The write down, the face is changed by the face is changed by plunging the telescope The phase is changed by plunging the telescope plunging the telescope plunging the telescope plunging the telescope and swinging it by 180 degree. Swinging it by 180 degree. Written.
Yes, sir.
Write on note the errors that are eliminated by the errors that are eliminated by errors that are eliminated by changing phase are changing phase are written.
Yes, sir.
First, error due to line of collimation not being error due to line of collimation not being errors due to line of collimation not being perpendicular to the horizontal axis, not being perpendicular to the horizontal axis. Written. Written.
Yes, sir.
Next, write down second error due to horizontal axis not being perpendicular to vertical axis. First, what you have written? First, what you have written? What you have written first?
Error.
First, what you have written, gentlemen? Tell me,
I forgot,
Danny.
sir.
First point, what you have written?
Uh, Errors due to.
Error due to line of collimation not being perpendicular to the horizontal axis. Written.
Yes, sir.
Second, error due to horizontal axis not being perpendicular to vertical axis. Error due to line of collimation not being error due to horizontal axis not being perpendicular to vertical axis. Second point. Written.
Yes, sir.
Third, error due to line of collimation not being parallel to the error due to line of collimation not being parallel to the error due to line of collimation not being parallel to the error due to line of collimation not being parallel to the axis of the altitude level. Axis of the altitude level. Written.
Yes, sir.
So these are the errors. All right.
Yes, sir.
Now write down axis of telescope. Axis of telescope. What is the axis of telescope? We have two lens. One is objective, that's known as object glass. Another is eyepiece. So when you are joining the when you are joining the center of objective or object glass to the center of eyepiece, that ray of light or that line is known as the axis of telescope. So write down, it's the line joining the it's the line joining the it's the line joining the optical center of the object glass. It's the line joining the optical center of the object glass. It is the line joining the object center of the optical center of the object glass or objective lens, optical center of the object glass or objective lens, optical center of the object glass or objective lens. Written.
Yes, sir.
To the center of the eyepiece. To the center of the eyepiece. Written.
Yes, sir.
Next, we will discuss next class. Okay.
Yes, sir.
Okay.